I'd like to start by thanking the organisers for inviting me to this conference today. And I'd like to say that Professor Mitra made some very important points. However, they're quite technical, and I'm going to try to explain things without getting into those sorts of technicalities. The first thing I'd like to explain to you is why black hole theory and Big Bang cosmology are mutually exclusive. Let's consider now the properties of a black hole universe. It's spatially infinite, is eternal, contains only one mass, is not expanding, and is asymptotically flat. This is by mathematical construction and hence definition. But Big Bang universes, on the other hand, are, well, in one case it's spatially finite, and in two cases it's spatially infinite. It's of a finite age. It contains radiation and many masses, including alleged multiple black holes. It's an expanding universe, and it is not asymptotically flat. We see straight away by mathematical definition, these two space-times are completely different. You cannot superpose a black hole universe into a Big Bang universe. They are defined in very different terms. You cannot superpose a black hole universe into another black hole universe. Otherwise, asymptotic flatness is violated. So you cannot get multiple black holes. Now, this alone is enough to show that you either have to have black holes or a Big Bang universe, but not both. Which one would you choose? Well, there are two options, three options actually. A black hole universe which describes nothing, a Big Bang universe which excludes black holes, or neither. I'm going to show you, in very simple terms, that the only possibility is neither. Now, there's a couple of notes here I'd like to point out. Einstein's field equations are nonlinear. Therefore, for gravitational fields, the principle of superposition is not valid. All multiple black holes are obtained by application of the principle of superposition. That violates the very basis of the theory. For instance, if you have two solutions, x and y, in scalars a and b, then the linear combination ax plus by is not a solution. There are no known solutions to Einstein's field equations for two or more masses, and there is no existence theorem by which you can even insert that there are latent solutions for two or more masses. So the whole concept of multiple masses is wishful thinking. So, as I said, multiple black holes and multiple masses are obtained by inadmissibly applying principle of superposition. Here we find, from a very important book, Dictionary of Geophysics, Astrophysics and Astronomy, a definition of a black hole. I'll read it out to you. Black holes were first discovered as purely mathematical solutions of Einstein's field equations. This solution, the Schwarzschild black hole, is a nonlinear solution of the Einstein equations of general relativity. It contains no matter and exists forever in an asymptotically flat spacetime. Now, according to Einstein's principle of general relativity, his principle of equivalence and his special theory of relativity must hold in sufficiently small finite regions of his gravitational field. Now, both the principle of equivalence and special relativity are defined in terms of the a priori presence of multiple, arbitrarily large, finite masses and photons. It is therefore impossible for the principle of equivalence and special relativity to manifest in a space-time that contains only one mass or contains no matter. But big equals 0, as we will see later, is alleged to be a space-time by mathematical construction that contains no matter. And that's from where we get the black hole. So I'm going to put up here words and equations. Now, the first thing to note is that Einstein's field equations couple the gravitational field contained in the curvature of space-time with its sources. So if there are no sources, you only have a space-time geometry, as I've given here in the first equation. Space-time geometry equals minus kappa times material sources. Minus kappa, that's just the coupling constant. Of a body is still present, even though it's all been removed. There are no sources, but by stating the problem in this way, he puts in another source. So it's taken out in that breath, and it's put back in the next breath. Well, that's a contradiction, and so it can't be a valid argument. So Rick equals 0 contains no material sources by mathematical construction. Here is Hilbert's solution Professor Mitra previously noted that this is actually Hilbert's solution. It's not Schwarzschild's solution at all, though it carries his name. And it's claimed that R equals 2m, there's a coordinate singularity to get a Schwarzschild radius, the radius of the event horizon of a black hole. And at R equals 0, it's claimed that it produces an infinitely dense point mass singularity. Hawking says that the work he and Roger Penrose did between 65 and 70 showed that according to general relativity there must be a singularity of infinite density within the black hole. He's referring to the paper in 1970 by he and Penrose on singularity theorems. Well, there was a paper published on the 5th of June this year which shows that the Hawking-Penrose theorems are fallacious. I'm going to rewrite Hilbert's solution without anything being hidden, because Hilbert's solution has C and G written as one. Here I'm putting them in explicitly, so nothing can be hidden anymore. We now can read off the components of the metric tensor. This is very simple. All you do is read off the coefficients. That's their names. G0 is the first coefficient, G11 is the second, etc. So we've got 4 of them. Now it's claimed that R equals 2gm over c squared, G0 equals 0, and G011 equals minus 1 over 0. It's minus infinity. Well, first, that's fallacious. You can't put in, the metric doesn't exist there. But where do we get this claim? From none other than Paul Dirac. There's the reference. He says when it's that value, G0 is 0, well, we can see if you put the value in for consistency, you get a minus infinity. What? Minus 1 divided by 0. That doesn't give us minus infinity because division by 0 is not even defined. That metric is not even defined there. So you cannot assign any physical property to that particular aspect, that particular value. But, nonetheless, the theory of black holes assigns a physical entity to it in the sense of the event horizon. Then it goes down, before I go on to that, notice that at R equals 2gm over c squared, we rearrange that and solve it for c. We immediately notice that we have Newton's expression for escape velocity. That's how the mass is actually put into the equation. Post hoc, you get a constant of integration. Because there's an idea that there's a mass present, because Einstein says it's outside of mass, we have to get a mass back in. How is it done? It's done by sticking in, arbitrarily, Newton's expression for escape velocity. And then it's claimed that the escape velocity of an event horizon of a black hole is the speed of light. And the radius of the event horizon is 2gm over c squared. But Newton's expression for escape velocity is an implicit two-body relation. What did we start with? We started with a space-time with no matter, but Einstein says there's one mass, but there's a two-mass implicit expression from Newton, arbitrarily inserted there to justify the alleged presence of a mass. It's in a one-body universe because it's asymptotically flat. Superposition does not apply because it's a nonlinear solution to a nonlinear set of equations, and it's in a four-dimensional pseudo-Riemannian space-time. But the Michel-Laplace body has an escape velocity. It has no gravitational collapse. It doesn't go to a singularity. It has no event horizon. It can always be seen, therefore, by a class of observers. It's in a multi-body universe. Superposition does apply. It's not in an asymptotically flat space-time, and it's in a three-dimensional Euclidean space. Well, those two things are entirely different. So the claim that the Michel-Laplace body, which is theoretical, but consistent with Newton's theory, is entirely fallacious, because the Michel-Laplace body does not possess the signatures of the alleged black hole. None of them. Now, we see what really R equals 2gm over c squared is. We know that it comes from Newton's theory by an arbitrary insertion of Newton's expression for escape velocity into Hilbert's metric in order to substantiate the claim that there is a mass present when it's all removed by setting the material sources to 0. We see that it has nothing to do with the black hole whatsoever. It is the critical radius for the formation of the theoretical Michel-Laplace dark body. And we see that the Michel-Laplace dark body has got nothing to do with the black hole It doesn't share the signatures. Now, Big Bang. The Big Bang cosmology models the universe as being entirely filled by a single homogeneous continuous distribution of matter of uniform macroscopic density and pressure. Why? Because there are no known solutions to Einstein's field equations for two or more masses, and there is no existence theorem where you can even claim that there are latent solutions for two or more masses. So Big Bang cosmology is forced to model the universe as a single body. Then the Big Bang universe goes out and galaxies form. Where did they come from? Galaxies start clumping up. Now we've got a multi-body problem. But we started out with a what? A one-body problem. So in other words, superposition has again been applied to get all these galaxies and stars and planets in a Big Bang universe, which we see is contradictory to a black hole universe. And we're told that there are multiple black holes, binary black holes merging and colliding to form other things. It's all application of superposition, which is invalid. So the whole argument for multiple black holes is proved again to be fallacious. But, of course, the black hole itself doesn't exist. Now, a really important thing here. General relativity violates the usual conservation of energy and momentum. That now completely gets rid of black holes and big bangs and all the rest of it in one step. Because unless you want to throw out all what we know of the conservation of energy and momentum and rewrite the whole of physics, right? You have to throw this away. Why? Because it violates it. Now let's see how Einstein tries to get around this problem. He puts in a thing called a pseudotensor. It has this symbol. It's written in mixed form. What does it mean, mixed form? It means if you write a tensor with some superscripts and some subscripts, it's called mixed. If all the suffixes are just subscripts, it's called covariant. If all the suffixes are superscripts, it's called contravariant. Well, we write it in the mixed term here, because I'm going to write Einstein's energy and momentum tensor shortly in mixed form. Einstein calls this thing here, the pseudotensor, the energy components of the gravitational field. There it is in his book, or his original paper, The Foundation of General Theory of Relativity. That means they vanish identically, and the usual conservation of energy and momentum is still violated. But we have now an energy expression in tensors and a set of field equations in tensors. So what are you in? The gravitational energy still can't be localised. That means the Einstein gravitational waves, they don't exist either. That's why no one's any found any. And the lambda here, well, it's a cosmological constant. So that's a quick overview. The details are pretty involved, but I think that this explains things pretty well with minimal mathematics. So thank you very much.